Quadratic function. Solving real life problems. To solve the real life problems, you may have to derive the quadratic functions. This time you might not have given the quadratic function, right? So in some information is given to you, and based on that information you need to decide the best form of the quadratic functions that you need to create. For example, I'm taking one exemplar for you. So read the statement here. You have 100 meter of fencing to enclose the rectangular plot. Find the plot maximum possible area. Determine the dimensions to give the maximum area. Right. So they are talking about a rectangular figure. So we need to exercise this information. We'll start with drawing a rectangle. So my rectangle is drawn, and what other information I have? The information is 100 meter of fencing. It means what? This rectangle is fenced from outside, and that fencing length is nothing but 100 meter. Right? Are you getting this? So this fencing length is 100 meter. So it means that if my length that represented by L and the breadth of the rectangle that represented by B, so this comes out twice of L plus twice of B, that is given to me 100. This is what information I have. This is the only information that I have, right? And from this information I'm going to create the area function, right? But first need to simplify this expression. So we have twice of L plus twice of B is equal to 100. Can't we take 2 as a common and put L plus B is equal to 100 by 2? So my L plus B is 50. Any doubts here? Now, can you tell me what is the area of rectangle? Yes. So area of rectangular plot is length time breadth, but we have L plus B given. So what I can do, I can make one term into another. What I mean to say, let's make length in terms of breadth. So length is nothing but 50 minus breadth, right? This I can write. I put breadth from the left hand side to the right hand side, right? So in place of length, I'll put 50 minus b, and there is times b already there. What I'm using equation 1. Now expand this. So what I'm getting, 50 times b minus b square. This is what my area expression, 50b minus b square, right? Now we are looking for find the plot maximum possible area. So maximum possible area, how do I get the maximum possible area? We know how to find the maximum or the minimum of the quadratic function, if you remember. That is the turning point, right? That is the vertex. Vertex gives me the maximum possible area, maximum possible dimension. So here I need to find the b value which will going to give me the max. So the for b max, by default we also use minus b over 2 if you remember, but this small b is from ax square plus bx plus c, right? So minus b over twice of a. What is the b here? B is the coefficient of basically this b here. Don't confuse with this 2b. uh, this b belongs to the actual general form of the quadratic. and this b is the breadth of the rectangle here. By default they are same here, but this b is the coefficient. So the coefficient here is negative 50, and a is negative 1. So what I'm getting, negative 50 times negative 2, which comes out 25, right? So b, the breadth, is comes out 25 meter. So what is the length comes out then? If I just figure out the length from 1, the length would be also 25, because I'll subtract 25 from 50. 25 minus 50, that is 25 meter, right? Now this is what I'm getting the answer for the dimensions. These are the dimensions of the rectangle. Basically, when the breadth and the length become 25 and 25, basically when my rectangle become a square of length 25 and 25, then it will going to give me the maximum area. So area maximum will be length times breadth, which is 25 times 25 meters square, which comes out 625 meters square. This is the maximum area of the given rectangle whose fencing is given to me 100 meter. Are you getting this? Right? Great.